Welcome to this video from Derby Physics Tuition, and I've been working with students studying A-level physics. We've been looking at periodic motion and namely circular motion, and we looked at this question and it's about a jet which is used in a flying display in which the pilot will be required to fly the jet in a horizontal circle of radius r. So here's our jet, and the pilot has to fly the jet in a horizontal circle. So how is this achieved? So this is achieved by flying the jet with its wings at 35 degrees to the horizontal. With the jet flying in this way, the two forces acting on the jet are the lift and the weight W. So both of those are shown in the diagram, and we can ignore air resistance for this particular question. So the first part is show that the magnitude of the force L is about 74 kilonewtons. So this is the first part. So let's have a look at how we solve part 1. Show that the magnitude of the force L is about 74 kilonewtons. Okay, so we're going to look at how we prove that first part. Now, this is part C of the original question, and the mass of the jet was given at the beginning as 6,200 kilograms. Okay, so we can work out the weight of the jet, which is mass times the gravitational field strength, which is 6,200 times 9.81. Okay, now to find out what L actually is, we need to resolve vertically. Okay, and the force acting vertically down is W, which is equal to 6,200 times 9.81, and that is balanced by the vertical component of L, the lift force, and the lift force is acting at an angle of 35 degrees. So the vertical component of the lift force is given by L cosine 35 degrees. So L will be equal to 6,200 times 9.81 divided by cosine 35 degrees. And if you work that out on your calculator, it comes out as 7.42 times 10 to the 4 newtons, which is approximately 74 kilonewtons. So we can write our final answer as 7.4 times 10 to the 4 newtons. Okay, and so we've proved that the magnitude of force L is about 74 kilonewtons, or 74,000 newtons. Okay, moving on to the next part of the question, part 2. Calculate the radius r. So we know that the lift force is 7.4 times 10 to the 4 newtons. Now, the plane is flying in a circle, and the reason I'm going through this question is to highlight a common mistake that students make when tackling this question. And the way that you calculate the radius r is using circular motion theory. Now, when something moves in a circle, there is a force acting towards the centre called the centripetal force, and we can calculate the centripetal force by using the formula mv squared over r, which is the radius of the circle. Okay, so we need to use the force acting towards the centre of the circle, which I've labelled F. Now, a common mistake is to use 74 kilonewtons or 74,000 newtons, which is what we calculated in the previous part of the question. But the actual value of the force acting towards the centre is the horizontal component of L. So the force acting towards the centre is actually L sine 35 degrees, and that equals mv squared over r. So if we put our numbers in, we've got 7.4 times 10 to the 4 sine 35 equals the mass 6,200 kilograms. Now we're given the speed that the jet is moving at, so that is 86 squared times the radius of the circle. Okay, so we can see there now that we have enough information to calculate that. So let's rearrange our equation. We've got that r will be 6,200 times 86 squared divided by 7.4 times 10 to the 4 sine 35 degrees. Okay, so just rearranging that to make r the subject, and we end up with a radius of 1,100 meters. So how are the three marks awarded? Okay, 1 mark for correctly identifying the horizontal component of the lift force, L sine 35, and the second mark for correctly rearranging and putting the correct numbers in, and the third mark is the final answer, which is 1,100 degrees. So I wanted to highlight this question because that's a common mistake, to not calculate the horizontal component. So you have to use the lift force and work out the horizontal component of that to find what we call the centripetal force. So hopefully you have found that useful, and if you do have any questions or comments, please do leave them in the comment section below the video. Thank you very much.